Alright, so in this video we're going to look at another one of our number systems. This one is the octal number system, and it is a base 8 number system. Okay, so this one's a little bit different, but it's actually one of the easiest ones to work with. Alright, so again we're going to be comparing this to binary. So the octal system allows us to basically send more binary information in less space, is the purpose of the octal number system. So the reason we use octal with binary is that it fits better. So it's an easier transition than our decimal system that we work with. So if you think about the binary number line that we talked about in the first video, it goes 1, 2, 4, 8, right? So 8 falls on that number line. So it just makes it easier to transfer that information. So again, not going to get into all the specifics about how the octal numbers work. Again, if you hadn't looked at the notes, go back and do that now on Blackboard. To read the specifics about it, then come back and watch this video. So here again we're going to focus on counting with octal numbers and converting octal numbers. Alright, so we're going to go ahead and jump into this. Alright, so again we'll start off with counting. So here again I'm doing a side-by-side comparison of the octal numbers compared to the decimal numbers. Alright, so with octal, there's only 8 possibilities, and that is 0 through 7. So 7 is as far as we can go. So in octal, 7 is like our 9 in the decimal number system. Okay, so that means that's as far as we can go per one place value, then we have to start over. Okay, so this makes the counting a whole lot easier and less confusing than it is with the binary number system. Okay, so all you have to really remember here is that 8s and 9s do not exist. It's only 0 through 7. So if I'm counting 0 through 7, 7 is as far as I can go. So that goes back to a 0, and I add 1 over here. So that is our 8 in octal. Then I have 1, 1, which would be 9. 1, 2, 10. 1, 3, which would be 11. 14, which would actually be 12. 15, 16, 17, and that would be in decimal 13, 14, and 15. And then remember, 7 is as far as I can go, so after 7 this goes back to a 0. I add 1 to the next place value, so that would be 20, which would actually be 16 in decimal. Okay, so don't get too concerned about the decimal equivalent here. Just know that when you're counting in octal, you go 0 through 7, add 1 to the place value to the left. Okay, so again, to give you an example, over here I've got just a random binary number, or excuse me, a random octal number, and we're going to count from that point. Okay, so again, we've got this subscript here to let us know that it is an octal number, base 8. Alright, so 64, after that would be 65, then 66, 67, and then remember 7 is as far as we can go. So that goes back to a 0, I add 1 to the right, to the left of that. So that's 70, 71, 72, 73, 74, 75, 76, 77, and then what would be next? Okay, remember 8s and 9s do not exist. So 7 goes back to a 0. That's as high as we can go. 7 is as far as we can go, so that goes to a 0. So now we have 100. So we jump from 77 to 100. Because again, this is not our decimal system, this is our octal number system, base 8. So after that would be 101, 102, 103, 104, 105, 106, 107. And remember, 7's as far as we can go. 0, 1 to the left. That one drops down. So then 110. Okay? So much easier to count with this number system because it's very, very similar to decimal. You just have to keep in mind that there are no 8s and 9s. So once you get to 7, that's your transition point. So that's how we count with the octal number system. Okay? So now we're going to jump into the conversions. So as I said at the beginning, the purpose of the octal number system is to work with binary to send that information in less space. So what we're going to focus on here is converting octal to binary, since that's what it's directly related to. Alright, so the first we're going to look at taking the octal number and converting it to binary. So this is actually a lot easier than the decimal to binary conversions that we looked at in the first video as well. Alright, so with going from binary to decimal, remember we had to use that whole entire number line to convert the value. But with octal to binary, we only have to know the first 3 places. So that's why I put here on the title page groups of 3. That's the key to remembering the conversions with the octal number system. So all I have to use is 1, 2, and 4. That's it. Okay? So what happens here is that each place value in octal is going to be worth 3 binary numbers. So every single place value here is worth 3 binary numbers. So I went ahead and wrote a couple of these 1, 2, 4s across the page here for each place value. Okay? So in a sense, I'm just subtracting out as I would if I'm going from decimal to binary. So here we're going octal to binary. So the first place value is a 0. Well, that's easy. 0 is 0. But remember, it's going to be a group of 3. So that first group of 3 is going to be 3 zeros. Alright, so the next place value is a 7. So again, I subtract it out. So 7 minus 4 is 3. 2 from 3 is 1. 1 from 1 is 0. Okay? So this group of 3 represents that 7. This group of 3 represents that 0. And now that's my answer. Okay? So I just put all this together. So my answer is 1, 1, 1, 0, 0, 0. Okay? So I don't leave that as 2 separate groups. I just push it all together. And that is my binary number. Okay? Real simple to do. Each place value is a group of 3. So in my next one, 256. So my 6, 4, and 2 give me 6. So that's going to be a 110. Now I have a 5. So 4 and 1 give me a 5. And then I have a 2. So I have a 1 in the 2's place. Okay, so again, I put that all together. So it's 0, 1, 0, 1, 0, 1, 1, 1, 0 for my answer. Alright. So my next one, I have a 1. So that's just a 1 in the 1's place. Other 2 are zeros. 7, we did that earlier. 4, 2, and 1 is 7. And then another 1, 0, 0, 1. Okay. Again, I put that all together, so 0, 0, 1, 1, 1, 1, 0, 0, 1. All right. So before I go further, I just want to talk about these. So these are not holding any significant place values, so you don't have to write these zeros leading here because it would really be no purpose to have that. But to keep everything in a group, if it's less confusing for you, just do it that way and write it down. That's fine. Okay. All right, so the last one here, I've got 6. So 0, or excuse me, 1, 1, 0. 4 and 2 is 6. Then I have a 2, which is 0, 1, 0. 1 in the 2's place. A 7. 4, 2, and 1 give me 7. And then a 4, which will just be a 1 in the 4's place, and 2 zeros. So again, I put all these together. So here I have 4 place values, so I have 4 groups of 3. So I put that all together: 1, 0, 0, 1, 1, 1, 0, 1, 0, and 1, 1, 0. Okay, so that's how I go from octal to binary, is just to break it up into groups of 3. So each single place value becomes a group of 3 binary numbers. I combine that all together to get my answer. All right, so next we'll look at doing the opposite, taking a binary number and converting it into octal. And it's again going to be basically just the opposite approach. So we're going to use those groups of 3 again. So that 1, 2, 4 of the binary number line. All right, so what I need to do for this, because I'm going from binary to octal, is I have to take this binary number and divide it up into groups of 3. All right, so to do that though, a very important thing here is that you start from the right and work your way to the left, okay? Because if you don't, that can throw off the value of your number. So always start from this point. So I got 3 and then 3. All right, so if it helps you, go ahead and write that number line up there: 1, 2, 4, 1, 2, 4. All right, so in this group of 3, I have 4 and 2, so that is 6. And then here I have just a 1 in the 2's place, so that's just a 2. And so that's my answer, 62. Okay, simple as that. All right, so my next one, I got 1, 2, 3, that's a group. 1, 2, 3, that's a group. 1, 2, 3, that's a group. So again, I can put my number line up here: 1, 2, 4, 1, 2, 4, 1, 2, 4. So with the first group, I've got a 4 and a 1, so that is 5. I've got 4, 2 and 1, a 7, and I got a 1 in the 1's place, and that's a 1, so that's 571. Okay, so again, just using that first 3 places makes it easy. So I got 3, then I have 3, and now here I only have 2. Okay, so this is the reason I said it's important that you start from the right and work your way left. So I can just throw another 0 out there to make it a complete group of 3. I couldn't do that if I started from the other end. I couldn't add a 0 down here because that would push the entire number up the number line and change its value. All right, so these 3, all zeros, so that's going to be a 0, 1 in the 4's place, and then here a 1 in the 2's place, 240. All right, and then the last one, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1 by itself. So 1 in the 4's place is 4, 2 and 1 is 3, 1 in the 2's place is 2, and then the 1 in the 1's place is 1. So that's 1,234. Okay? So by doing these groups of 3, your answer over here will always be an octal number. So you should never end up with an 8 or a 9 over here, because that's not a possibility by only using 3 place values of the binary number line. Okay? So it's real easy to do the conversions to and from binary just using the first 3 places of the number line, 1, 2, and 4, and making groups for each place value. So again, a group of 3 in binary is always worth 1 place value in octal. All right, so hopefully that helps you understand better how to count and convert with the octal number system. Again, go through and look at those notes on octal, and if you have any questions about octal, just let me know. All right, thank you.